Welcome to MRL. In this learning session, we'll be learning the solutions of algebraic identities of exercise set 4.1 Ganita Manjari 9th standard NCERT textbook. Now in the first question here, we have been asked to expand the square of 7x plus 4y, and we have to use an identity. Now 7x plus 4y square is nothing but a plus b whole to square. Therefore the identity which can be used is a plus b whole to square is equal to a square plus 2ab plus b square. And here a is 7x and b is 4y. So put the value of a and b in the RHS here. So we get 7x whole to square plus 2 in the bracket 7x into 4y plus 4y whole to square. 7 square is 49x square. 7 to the 14, 56 xy, and 4 square is 16 y square. So that is the expansion of the given 7x plus 4y whole to square there. Next example is 7 by 5x plus 3 by 2y whole to square. Again the same identity is used. A is 7 by 5x and b is 3 by 2y. So it will be a square plus 2ab plus b square. So a square is 7 by 5x whole to square plus 2 in the bracket 7 by 5x in the bracket 3 by 2y plus 3 by 2y whole to square. So 7 square is 49, 5 square is 25, x whole to square is x square. 2 into 7. So please understand here, multiply the coefficients first. 2 into 7 by 5 into 3 by 2, x into y, plus 3 square is 9, 2 square is 4 and y square. And here 2 and 2 gets cancelled. So 49 by 25 x square, 7 3 is 21 divided by 5 xy plus 9 by 4 y square is the expansion of the given square of 7 by 5x plus 3 by 2y. Now the next example is 2.5p plus 1.5q whole to square. Again the same identity. So a is 2.5p and b is 1.5q. Putting the values in the RHS here, we get 2.5p whole to square plus 2 into 2.5p into 1.5q plus 1.5q whole to square. So 2.5 square is 6.25 and p square, and 2 into 2.5 into 1.5 becomes 7.5pq, and plus 1.5 whole to square is 2.25 q square. I believe that you know how to find the squares of numbers which you already learnt and you know it. Okay, understand that. Now coming to the next example, 3 by 4s plus 8t whole to square. Again a plus b whole to square, a square plus 2ab plus b square. A is 3 by 4s and b is 8t here. So putting the values in the RHS, we get a square is 3 by 4s whole to square plus 2 times ab, that is 3 by 4s into 8t plus 8t whole to square, that is b square. Then 3 square is 9, 4 square is 16, s square, and here multiply the coefficients. 2 into 3 by 4 into 8, s into t, and 8 square is 64 t square, 2 to the 4 and 2 4 the 8, so 4 3 the 12, 12 st here, 9 by 16 s square plus 12 st plus 64 t square is the answer. The next example is x plus 1 by 2y whole to square, and again applying the same identity, the a plus b whole to square is equal to a square plus 2ab plus b square, and putting the values of a and b in the RHS. A is x here, b is 1 by 2y, therefore it is x whole to square plus 2a, 2 into x into b, 1 by 2y plus 1 by 2y whole to square, and it will be x square plus 2 cancels here, x by y, and 1 by 2 square is 4 and y square. So that is what is the answer. Please make these corrections which I have made there already. Now the next example is 1 by x plus 1 by whole to square. It is equal to a square plus 2ab plus b square. So 1 by x whole to square plus 2ab plus b whole to square, that is 1 by y whole to square. So 1 by x whole to square becomes 1 by x square plus 2 divided by xy and 1 by y square. So that is the solution of that, expansion of that. Now the second example, to find the values using identity, we are given the example here, 60, we have to find 64 square, and 64 can be written as 60 plus 4 whole to square, and we can use the identity a plus b whole to square is equal to a square plus 2b plus b square. Here a is 60 and b is equal to 4. So putting the values in the RHS, a square is 60 square plus 2ab is 2 into 60 into 4 plus 4 square, that is 60 square is 3600, and 2ab is 2 into 60 into 4, that will be 6 to the 12, 12 for the 48, 480, and 4 square is 16, adding we get 4096. Now the next example is 105 whole to square. We can write 105 is 100 plus 5 and whole to 2, and 100, that means a square is 100 square here, and b then 2ab, that is 2 into 100 into 5, and b square is 5 square. So 100 square is 10,000, it will be 1025. When we add, we get 11,025 is the answer of 105 whole to 2. Now coming to the next example, 205 square. Now 205 can be written as 200 plus 5 whole to square, and applying again the same identity, a square is 200 square plus 2ab is 2 into 200 into 5, and b square is 5 square. So 2 square is 4 followed by 4 zeros, and 5 to the 10, 10 to the 20, and that is 5 to the 10, 10 to the 20 followed by 2 zeros, and 5 square is 25. So adding we get 42,025 is the answer. Now coming to the next exercise of identities chapter, exercise set 4.2 of Ganita Manjari again, that is 9th NCERT textbook. Now in this example, the first example we have to factorize. We are given a polynomial here, 9x square plus 24xy plus 16y square, and we have to factorize this. And for factorization, we know that we have got different methods: taking HCF common, grouping and taking HCF common, middle term splitting method, identity method, factor theorem method. And now here, since we are talking about identities, we have to apply the or use the identities. And now we know the identity a square plus 2ab plus b square is equal to a plus b whole to square. That means we have the first term as a square, the last term as b square, the middle term is 2ab. Now we have to check whether this given polynomial is equivalent to this identity. So 9x square can be written as 3x whole to square, and this will be 2ab. a is 3x here, and 16y square can be written as 4y square, and b becomes 4y. So if you multiply and see, if you take the square of this is 9x square, it is correct. 3 to the 6 for the 24xy is correct, and 4y square is correct, and therefore it is 100% a square plus 2ab plus b square form. And I can use the RHS here, a plus b whole to square. So a is 3x here and b is 4y, therefore it will be 3x plus 4y whole to square. So this is 100% an expansion of 3x plus 4y whole to square. Therefore the factors are 3x plus 4y and 3x plus 4y. So that is how we use identities to factorize a given polynomial. Now here we have a second example, 4a square plus 20st plus 25t square. Again, let us first bring it into a standard form of any one of the identities. So a square plus 2b plus b square again. So 4a square is 2s whole to square, and 2ab will be 2 into 2s into 5t square, that is 5t. This becomes 5t square, therefore 5t. So we have a square plus 2ab plus b square. That means a plus b whole to square, 2s plus a 5t whole to square. So the factors are 2s plus 5t into 2s plus 5t. So we have to check whether it is of the form of any one of those identities there. Now next example is 49x square plus 28xy plus 4y square. 49x square can be written as 7x whole to square. The first term and the third term is there are square terms there. So 7x whole to square and 2y whole to square. Now let us check whether 2ab is correct. 2 into 7x into 2y becomes 7 to the 4 into the 100% correct it is. The middle term is also correct, and therefore it is a square plus 2ab plus b square form. So we can take it as 7x plus 2y whole to square, because a is 7x and b is 2y. Therefore the factors are 7x plus 2y into 7x plus 2y. Now the next example is 64p square plus 32 by 3pq plus 4 by 9q square. So let us say 64p square and 4 by 9q square, they are square terms. 64p square is 8p square, and 4 by 9 q square is 2q by 3 whole to square. We have got the first term and the third term as square terms. Now let us see whether the middle term is 2ab or not. So it is 2 into 8p, because a is 8p and b is 2 by 3q. If we simplify this, then we get 3 as it is, a to the 16 to 100% it is correct, and therefore the a is 8p here and b is 2q by 3. Therefore the expansion is 8p plus 2q by 3 whole to square. Therefore the factors are 8p plus 2q by 3 into 8p plus 2q by 3. But very interestingly here we have 2 is common in this, so I can take 2 outside. So 2 4s are 8, so it becomes 4p, and 2 is outside and q by 3. Here also 2 is common, I can take 2 outside, it will be 4p plus q by 3. 2 into 2 becomes 4, 4 into 4p plus q by 3, 4p plus q by 3. So these are the factors of the given polynomial. Okay, now we can even do this example by taking the initial stage itself. That is what I have shown here. In this I have 4 common, so I have taken 4 outside. So it will be 16p square plus 8 by 3pq plus 1 by 9q whole to square q square. So apply the identity here and get the same answer. Either you go by this method or this method, both the methods are correct. But the better is you take 4 common first and then go for the application of identity. Now the next example is 3a square plus 4ab plus 4 by 3b square. And what I have done here is I have taken 1 by 3 common. When I take 1 by 3 common, this becomes 3 into 3, 9, because when I divide by 9, divide 9 by 3, I get 3 here, and this becomes 4 3 the 12, because when I divide 12 by 3, I get 4ab there, and 1 by 3, that it becomes 4 by 3b square, 4 by 3b square, correct it is. So therefore now I have 1 by 3 outside, and 9a square is 3a whole raised to square, and 4b square is 2b whole raised to square. The middle term is 2 into 3a into 2b. When I multiply 3 to the 6 is 12, 12ab, and is correct it is. So therefore this is expansion of a plus b whole to square, that is 3a plus 2b whole to square. Therefore the factors are 1 by 3 in the bracket 3a plus 2b into 3a plus 2b, and that's the correct answer. Now coming to the next example, 9 by 5s square plus 6sv plus 5v square. Now in this I will take 1 by 5 outside, and this is done by inspection. Okay, that is, it's not necessary that we can do it by inspection. Therefore I have taken 1 by 5, and when I take 1 by 5 outside, I get 9s square inside, because 9 by 5 square is, I am getting that. And here since I am dividing 30 by 5, I will get 6 here, therefore it will be 30sv, and 5 divided, this is 25, 25 divided by 5 is 5v square. Therefore I have changed the coefficients of v and coefficient of v square. Please try to understand that. Now 1 upon 5 is equal to 9s square is 3s square, and 25v square is 5v square. The middle term is 2ab, a is 3s, and b is 5v, and multiply this, 5 to the 15 to 100% correct it is. Therefore it is expansion of a plus b whole to square. So a is 3s here, and b is 5v, so 3s plus 5v whole to square. The factors are 1 by 5, 3s plus 5v, and 3s plus 5v. Try to remember that. Now coming to the next example, we have to find out the value using identity. Now we have to find out 79 square here, and 79 can be written as 18 minus 1 whole to square. That means it is a minus b whole to square form. We know that a minus b whole to square is equal to a square minus 2a. Now the second example, to find the value using identity. Now the first example given here is 79 square. 79 can be written as 80 minus 1 whole to square, and we can use the identity a minus b whole to square, and we know that a minus b whole to square is equal to a square minus 2ab plus b square, and a is 80 here and b is 1. So it will be 80 square minus the 2ab, because b is 1 square here. So 2 into a is 80 into 1 plus 1 square, and 80 square is 1600, and this will be 160 minus 160 plus 1, and adding 1601 we get 1601 minus 160 becomes 1441 is the square of 79. Now coming to the next example, that is 193 whole to square. 193 can be written as 200 minus 7 whole to square, and it is a minus b whole to square form again. So that is a square minus 2ab plus b square. But here a is 200, and b is 7. So it will be 200 square 7 square, and 2ab will be 2 into 200 into 7. So it will be 200 square minus 2 into 200 into 7 plus 7 square. 200 square is 2 square is 4 followed by 4 zeros. It will be 2 2s are 4, 7s are 28 followed by 2 zeros. 7 square is 49. Add 49 to 40,000, we get 40,049 minus 2,800, we get 37,249 is the answer. So 193 square is 37,249. Now coming to the next example, 299 square. 299 can be written as 300 minus 1 whole to square, and it is a square minus 2ab plus b square form again. A is 300, b is 1, so it will be 300 square minus 2ab. b is 1 here, a is 300, so 2ab is 2 into 300 into 1 plus 1 square, and 3 square is 9 followed by 4 zeros. 3 to the 6 followed by 2 zeros, and 1 square is 1. Adding 1 to 90,000 we get 90,001 minus 600 we get 89,401 is the answer. Now coming to the next exercise 4.3 of Ganita Manjari Identities chapter, now of 9th standard NCERT textbook. Now the first question here is to find the squares using suitable identities. Again, identities we have to use. Let us see how to do it. Now the first question is 117 square. Now 117 square can be written as 100 plus 10 plus 7. That means it will be a plus b plus c whole to square form. So we have an identity a plus b plus c square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca, and here a is 100, b is 10, and c is 7. So substitute the values in the RHS here. We get 100 square a square, b square is 10 square, c square is 7 square, and 2ab is 2 into 100 into 10, 2bc is 2 into 10 into 7, and 2ca is 2 into 7 into 100. Now simplify it, a simple thing there. 100 square is 1 followed, that is 1 followed by 4 zeros. 10 square is 100, 7 square is 49. It will be 2 followed by 30 because 2000 it is, and it will be 140, and it will be 7 to the 14, that is 1400. Now add all this, we get 13,689 is the answer of 117 square. Now coming to 78 square, it can be written as 80 minus 2 whole to square. Please understand this is 80, therefore 80 minus 2 whole to square. So a minus b whole to square, that is a square minus 2ab plus b square. A square is 80 square and b square is 2 square, and 2ab will be minus 2 into 80 into b, that is 2. Now 80 square is 6400, minus 2 into 2 is 4, 4 is 32, 320, 2 square is 4. Now 6400 plus 4 is 6404, minus 320 becomes 6084 is the square of 78. So try to understand that. Now coming to the next example, that is 198 whole to square, and 198 can be written as 200 minus 2 whole to square, that is a minus b whole to square. A minus b whole to square is a square minus 2ab plus b square. A is 200, b is 2, and therefore a square is 200 square, minus 2ab will be minus 2 into 200 into 2, and b square is 2 square. So 2 square is 4 followed by 4 zeros, and this will be 800, and this will be 4. Now 40,000 plus 4 is 40,004, minus 800 becomes 39,204 is the square of 198. Now coming to the next example, that is 214 whole to 2. Now we can write 214 as 200 plus 10 plus 4 whole to square, using the identity a plus b plus c whole to square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Here a is 200, b is 10, and c is 4. So therefore a square will be 200 square, b square is 10 square, c square is 4 square. 2ab will be 2 into 200 into 10, 2bc will be 2 into 10 into 4, and 2ca will be 2 into 4 into 200. Now simplify this. 2 square is 4 followed by 4 zeros, 10 square is 100, 4 square is 16, 2 to the 4, 10 the 40, 4000, 2 into 10 is 20, 24 the 80, 4 to the 8, 8 to the 16, 1600. Add all these, we get 45,796 is the square of 214. Try to understand that. Now coming to the next example, that is 1104 square. Now 1104 square can be written as 1000 plus 100 plus 4, and using the identity a plus b plus c whole to square, here we get a is 1000, b is 100, and c is 4. So a square will be 1000 square, b square will be 100 square, c square will be 4 square. 2ab will be 2 into 1000 into 100, 2bc will be 2 into 100 into 4, plus 2ca will be 2 into 4 into 1000. So multiplying, squaring this, we get 1 followed by 6 zeros. Squaring this, we get 1 followed by 4 zeros. 4 square is 16, and here 2 into 1 is 2 followed by 5 zeros, and 2 into 100 into 4, that is 4 to the 8, 800, and 4 to the 8, 8000. Add all these, we get 1018816 is the answer for 1004 square. So try to understand that. Now coming to the next example, 1120 whole to square. Again it can write it in three terms there, a plus b plus c, 1000 plus 100 plus 20 whole to square. Again using the same identity, that is a plus b plus c whole to square becomes a square is 1000 square, b square is 100 square, c square is 20 square. 2ab will be 2 into 1000 into 100, 2bc will be 2 into 100 into 20, 2ca will be 2 into 20 into 1000. Now square of this will be 1 followed by 6 zeros, this will be 1 followed by 4 zeros, this will be 2 square is 400, and this will be 2 followed by 5 zeros, and 2 into 2 is 4, 4000, and 2 into 2, 4, 40,000. So adding all this, we get 1254400 is the square of 1120 whole to square. So please understand that. Now coming to the next example, that is example number 2, we have to factorize here. Now again we have to use identities. The first term is a square term, the third term is a square term, that means it is 4y whole to square, this is 3 square. Now let us see whether we get the middle term. Now 2 into ab, a is 4y and b is 3, 2 into 4y into 3 becomes 4 to the 8, it is 24, correct it is, the middle term we have got it. Therefore it is a minus b whole to square, therefore 4y minus 3 whole to square, therefore the factors are 4y minus 3 into 4y minus 3. Remember that. Now coming to the next example, that is 9 by 4 s square plus 6 st plus 40 square. The first term is a square term, the last term is a square term. This becomes 3 by 2 s whole to square, and this is 2t whole to square. Now we have to check the middle term. So 2ab, 2 into 3 by 2 s into 2t. Now here 2 and 2 cancels, 3 to the 6 and st, and is correct, middle term is correct. Therefore it is a plus b whole to square form. A is 3 by 2s and b is 2t, and plus 3 by s plus 2t whole to square. Therefore the factors are 3 by 2s plus 2t, 3 by 2s plus 2t are the factors of the given polynomial. Now here we are given a lengthy polynomial, that is m square by 9 plus mk by 3 plus k square by 4 plus 3nk plus 2mn plus 9n square. Now let us understand how to use an identity here. Now this is a square term, m square by 9 is a square term, k square by 4 is also a square term, and 9n square is also a square term. Let us bring all of them together. So m square by 9, k square by 4 and 9n square. That means these three are square terms. That is m by 3 whole to square, k by 2 whole to square and 3n whole to square. Now the question is whether these three terms are 2ab, 2bc and 2ca. So let us understand 2 ab, m by 3, k by 2, 2ca, 2 k by 2 and 3n, and 2 ca, that is 2 3n and m by 3. Now simplify this. 2 cancels here, mk by 3, correct it is, and here 2 cancels, it is 3nk, it is correct, and 3 cancels to mn. 100% it is an expansion of a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Therefore it is the square of a plus b plus c whole to square, whereas a is m by 3, b is k by 2 and c is 3n. Therefore it is m by 3 plus k by 2 plus 3n whole to square, and the factors are m by 3 plus k by 2 plus 3n into m by 3 plus k by 2 plus 3n. So that is how we use an identity to find the factors. Now the next example is p square by 16 minus 2 plus 16 by p square. Again we have got the first term as a square term, third term is also a square term. P square by 16 is p by 4 whole to square, and this will be 4 by p whole to square. Now we have to check whether the middle term is correct or not. So now middle term is 2ab, so it will be minus 2 into p by 4 into 4 by p. 4 cancels, p cancels, and 2, 100% correct it is. So it is the form a square minus 2ab plus b square form. Therefore it will be a minus b whole to square. A is p by 4 and b is 4 by p. So p by 4 minus 4 by p whole to square is the correct identity used here, and therefore the factors are p by 4 minus 4p into p by 4 minus 4p, and 100% correct answer. Now again we have a polynomial given here, and we have to use an identity to find the factors. It is a square term. First this is a square term, this is a square term, this is a square term. That means it is 3a raised to square. This is 4b, I have taken it as minus, I will tell you why it is. I have taken minus here, it is minus 2b whole to square, and this is c square. Now we have got the first three terms, that is a square plus b square plus c square, we have got it. Now let us see whether we get how to get 2ab. Now 2 into 3a, it is correct, and minus 2b. So let us see whether it is correct or not. See, plus into minus is minus, 3 to the 6, 6 to the 12, 12ab is correct. Now 2bc, 2 into minus 2b into c, bc, because c is c here only, c is also c only, and therefore plus into minus is minus 2 to the 4, 4bc, it is there. Now come to the third term, 2c into 3a, 2c into 3a becomes 3 to the 6 ac, and that is plus. So therefore if I had not taken minus here, I would not have got these two minus signs here. Therefore I have taken minus 2b whole to square, and be careful about this taking minus sign. Better write it with the pencil first and then correct it, so that there won't be any correction to be made, or any scratch has to be scratching will be there in the calculations. Now therefore this is expansion of a square plus b square plus c square plus 2ab plus 2bc plus 2c, expansion of 3a minus 2b plus c whole to square, and therefore the factors are 3a minus 2b plus c and 3a minus 2b plus c. Try to understand that. Now coming to the example, expand using identity. We have to expand this using identity. A very simple thing again. A plus b plus c whole to square, we know that it is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. So apply that. A is p here, so p square. B is 3q here, 3q square, and c is 7r, 7r square. And 2ab will be 2p into 3q, and 2bc will be 2 into 3q into cr, and 2ca is 2 into 7r into p. Now multiply them. P is p square, p whole to 2 is p square, this is 9q square, this is 49r square, this will be 6pq, this will be 3 to the 6 and the 42qr, and this will be 7 to the 14rp. So that is how we can use an identity to write the expansion of the given square of any polynomial. Now again here the same identity we have to use. So 3x whole to square, 3x whole to square, b square will be minus 2y whole to square, c square is 4z whole to square, 2ab will be 2 into 3x into minus 2y, and 2bc will be 2 into minus 2y into 4z, and this will be 2ca 2 into 4z into 3x. Now square it. 3 square is 9 x square. This will be 2 square, or that is 4, and y square minus 2 square becomes plus 4, so 4y square. This will be 16z square. Plus into minus is minus 3 to the 6 to the 12xy. Plus into minus is minus 3 to the 4, 4 for the 16yz. Plus only, and 4 to the 8 is the 24zx is the expansion of the given square of a polynomial. Now the next example is we have to find the square of 55, and 55 can be written as 50 plus 5 whole to square, and it is a square plus 2ab plus b square. A is 50 here and b is 5, therefore I can write it as 50 square plus 2ab, 2 into 50 into 5, and b square is 5 square. 50 square is 2500, it will be 5 5 is 25 to the 500, and 5 square is 25. When we add, we get 3025. So that is one method of solving finding the square of 55 using the identity a square minus b square, using the identity a plus b whole to square is equal to a square plus 2ab plus b square. But also there is a second method which we can use. Now we know that a square minus b square is equal to a plus b into a minus b. That means a square is equal to a plus b, a minus b. Taking b square, that side becomes plus b square. So we can use even this identity to solve or find the value of 55 square. Now applying this identity, if a is taken as 55 here and b is taken as 5, so it will be 55 plus 5, 55 minus 5, and b will be b square will be 5 square. So 55 plus 5 is 60, 55 minus 5 is 50, and 5 square is 25. So it will be 60, 6 into 5 is 3000 plus 25, 3025. Again the same answer, but it is slightly different identity used here. We have to be careful in using this identity so that we can substitute the values correctly and get the answer. But the easier method is to find using the identity a plus b whole to square, which is equal to a square plus 2ab plus b square. So that would be more preferable. Okay, then understand that. So that is how we have solved all the examples of these exercises here using identities. The important thing is to know the identities, remember the identities, and apply the identities, and choose the correct identities to solve the example. That is exactly what is this chapter about. So learning about identities, rather exploring the identities. So that is how we have explored using the identities in solving the example. So try to remember them, note down them in a book, and so that will be a reference for your future use, and learn the basics, remember the identities, solve them. Okay, thank you.